This instrument behind me is probably one of the coolest instruments I've ever used, and it's called an electron microscope. They're used to image samples that are smaller than wavelengths of light, and that includes things like nanoparticles and proteins and viruses. Instead of using light like a normal microscope, it uses a beam of electrons fired through your sample and onto a detector element. And instead of using glass lenses, it uses magnets to focus and control the beam of electrons. This little port right here is where your sample goes, and you insert your sample on a sample arm, and that goes directly into the beam. All of these other knobs, like this one or this one, are adjustment knobs to adjust the focus and correct the electron beam. And this is a cold trap to prevent contamination of the vacuum. And you can either visualize your sample on this screen that has like a phosphorescent material and look through these eyepieces, or you can look on the computer to see your image. This little thing right here is a sample grid. It's a piece of copper foil, essentially, with a coating of carbon for your sample to go on top of. And here's a penny just for scale. And here's a close-up image of that grid under a microscope, a normal microscope. You can see all these little squares on it. These little squares are covered with a carbon film. And when you put your sample on it, the sample sits in there and you image in these little grids. And you get images like this. All of this gray area in the background is that grid that you saw, or the in-between of the grid. And these little dark dots are my sample. These are lead selenide quantum dots. To give you an idea of how small these things are, that scale bar right there is 20 nanometers. That is 20 billionths of a meter. And if you zoom in even further, you can see the atomic lattice of the material. So these lines right here, or like here, are the actual crystalline lattice of this material. And since every material has a lattice constant, what I could do is I could measure the spacing between each of these and compare it to known materials and figure out what material this is if I didn't know what it was. This is Mad Bioengineer signing off.